NEC Article 230.6 dictates that service entrance conductors must be installed in a raceway routed outside the building. This requirement is primarily for safety, aiming to protect the conductors from physical damage and to mitigate the risk of fire should they become energized. The argument that a utilities metering installation falls outside the scope of the NEC is not entirely valid. NEC Article 90.3b clarifies the code's applicability. It states that the NEC applies to essentially all electrical installations unless a specific exemption is provided. Metering installations are not generally exempt, therefore, they are subject to the NEC regulations. Furthermore, the assertion that meter wires are not service entrance conductors is contestable. According to NEC Article 100, service entrance conductors are defined as the conductors connecting the service equipment to the supply line outside the building. In a typical metering setup, the wires connecting the current transformers and potential transformers (CT/PTs) to the meter would indeed qualify as service entrance conductors. The inspector's concerns regarding the potential fault current hazards from the metering CT/PT are legitimate. Damage to the conduit could lead to a fault, causing an arc flash. Arc flashes pose significant risks, potentially leading to injuries or property damage. The correct installation method is to ensure the conduit is routed outside the building, as stipulated by NEC Article 230.6. When changing a customer's metering method from secondary to primary, adhering to the National Electrical Code is paramount. A scenario involves installing a primary metered combination current transformer/potential transformer CT/PT 15 kV low profile low break fuse switch outdoors to protect the existing service transformer. A 1.5-inch rigid metal conduit RMC is routed exposed through the adjacent mechanical room to a new utility-owned wall-mounted meter location within the room, approximately 20 feet from the outside wall. The utility provides a heavy-duty 9-conductor metering flexible cable, installed in the conduit according to utility specifications, terminated at the CT/PT and the meter interface. An electrical inspector identifies a violation of NEC Article 230, stating the conduit was not routed outside the building. The utility contends the meter and wiring method are under the jurisdiction and maintenance, thus the code does not cover electric utility metering as per NEC Article 90.3b5a. They also argue the meter wires are not service entrance conductors subject to Article 230. Installations involving double-ended service substations often see meters mounted remote from the substation equipment, using exposed RMC between the CT/PT sections and the meters, complying with utility specifications without issue. Similarly, secondary to primary metering conversions are often implemented in other cities exactly as described without violations. The electrical inspector is correct. The primary concern revolves around the definition and routing requirements of service entrance conductors. The National Electrical Code, NEC, specifically Article 230.6, mandates that service entrance conductors be installed in a raceway and routed outside the building. This requirement is in place to ensure the protection of these conductors from physical damage and to prevent them from potentially causing a fire or other hazards should they become energized or experience a fault. The utility's argument that their metering equipment and wiring methods are solely under their jurisdiction and maintenance is not entirely valid. NEC Article 90.3 clarifies the scope of the code, stating it applies to all electrical installations except those specifically exempted. Metering installations in general are not explicitly exempted. Therefore, they fall under the purview of the NEC. The argument that the meter wires are not service entrance conductors is also flawed. NEC Article 100 defines service entrance conductors as those conductors that connect the service equipment, such as the CT/PT in this case, to the supply line located outside the building. The wires connecting the CT/PT to the meter are therefore classified as service entrance conductors, as they fulfill this connection role. The electrical inspector's concern about the potential fault current danger originating from the metering CT/PT is valid. While the power required to operate the meter is relatively low, a fault in the system, particularly if the conduit were to be damaged, could lead to an arc flash or other hazardous condition. These events can pose significant risks of injury to personnel and damage to property. The recommended approach for ensuring code compliance involves routing the conduit outside the building. This approach aligns with the requirements of NEC Article 230.6 and effectively mitigates potential safety hazards. The argument that the metering wires are not service entrance conductors is incorrect. Service entrance conductors are defined in Article 100 of the NEC. They encompass conductors from the service point to the service disconnecting means. The service point is defined as the point of connection between the serving utility and the premises wiring. In the described scenario, the conductors from the CT/PT to the meter are indeed service entrance conductors as they connect the utility supply to the customer's service equipment. Article 230.6 is very clear. Service entrance conductors must be installed in a raceway or cable approved for the purpose and must be installed outside or under the building. This means that the conduit containing the metering wires must either run along the exterior of the building or be buried underground. The fact that the utility owns and maintains the metering equipment does not exempt it from the requirements of the NEC. Article 90.3b clarifies that the NEC applies to all electrical installations except for those specifically exempted. There is no specific exemption for utility-owned metering equipment. The purpose of Article 230.6 is to protect the building and its occupants from fire and electrical shock hazards. By requiring service entrance conductors to be installed outside the building, the risk of a fault within the building is reduced. While the power used by the meter itself is relatively small, the potential fault current from the CT/PT can be significant. If the conduit were to be damaged, a fault could cause an arc flash, which could result in serious injury or death. The fact that similar installations have been done in other cities without violations does not change the requirements of the NEC. The electrical inspector in this case is correct. The installation violates Article 230.6 of the NEC because the service entrance conductors are not installed outside the building. The utilities' arguments that the metering equipment is under their jurisdiction and that the meter wires are not service entrance conductors are both incorrect. The correct way to install the conduit is to route it outside the building, as required by the NEC. The NEC stance on service entrance conductors is further reinforced by considering the overall system safety. The CT/PT units, while designed to provide a scaled-down representation of the current and voltage for metering purposes, are still connected to the high-voltage service. A fault in these components, or in the wiring connecting them to the meter, can have serious consequences. The limited power needed for the meter's operation is not the primary concern, but rather the potential for high fault currents that could occur in the event of installation failure or equipment malfunction. The routing of the conduit outside the building acts as a physical barrier, isolating potential faults from the building's interior and reducing the risk of fire or electrical hazards spreading within the structure. The utility specifications, while important for the proper functioning and maintenance of the metering equipment, cannot supersede the safety requirements outlined in the NEC. Electrical inspectors are responsible for enforcing the NEC to ensure the safety of buildings and their occupants. Their interpretation of the code, in this case, is accurate and necessary to prevent potential hazards. The NEC requirements are not arbitrary. They are based on years of experience and analysis of electrical incidents. The code is constantly updated to reflect new technologies and to address emerging safety concerns. Ignoring or circumventing these requirements can have serious consequences. In cases where there are disagreements between the utility and the electrical inspector, it is important to consult with a qualified electrical engineer or other expert who can provide an objective interpretation of the code and help to find a solution that meets both the utility's operational needs and the NEC safety requirements. The inspector's perspective is rooted in the fundamental principle of safeguarding the building and its occupants from potential electrical hazards. Allowing the conduit to run inside the building creates a potential pathway for fault currents, increasing the risk of fire or electrical shock. The utility's argument that the meter wires are not service entrance conductors is a misinterpretation of the NEC definition. The NEC defines service entrance conductors based on their function and location within the electrical system, not on who owns or maintains them. Even though the utility owns the metering equipment, the wires connecting it to the service equipment are still considered service entrance conductors and are subject to the NEC requirements. The correct installation method, as per the NEC, is to route the conduit outside the building. This ensures that any potential faults are contained outside the building, minimizing the risk of harm to people and property. It is always best to err on the side of caution when dealing with electrical safety. The NEC is a comprehensive set of rules designed to protect people and property from electrical hazards. Following the NEC requirements, even when they seem inconvenient, is the best way to ensure a safe and reliable electrical system.